A circle C has center M of coordinates 6 and 4, that will be x and y, and radius 3. Write the equation of the circle in the form of x minus a squared plus y minus b squared plus r squared. In this situation, you've been given your a value, so this is your a, and that's your b. So in this case, it's going to be x minus 6 squared plus y minus 4 squared equals your r is 3, so that'll be 3 squared. And that's all they ask you to do. And that's 2 marks. Just to explain what's going on there, you have a circle. So if you have your x and y coordinates, and you've been told that your circle is 6 and 4, so if that was 6, and that's 4, so that's 4, and this is 6. And you draw a circle with a radius of 3. If you then pick a point on the circumference, that will be x and y. And ideally, you want to find the height here and the width, and that's the radius, which is r. So if you trace those points, that's your 6 and that's your x. You can see your x is bigger than your 6, so that's why we say x minus 6 squared, because we're applying Pythagoras theorem to this. X minus 6 squared. And for y, if you trace that y value there, you see that's y. Y is bigger than 4, and then we say y minus 4 squared. And then, so that height here is y minus 4, and this length here is x minus 6. So you know how to find the Pythagoras theorem. The height squared plus the length squared will be equal to the square of the hypotenuse. So it will be x minus 6 squared plus y minus 4 squared equals to the radius squared, which is, in this case, 3 squared. And that's the equation, really, that they're asking us to portray, to write down. B part, show that the angle TMQ, so we're looking for M, is 1.0766 radians to 4 decimal places. So we're talking about that angle here. We need to show that our angle is 1.7066 radians. Well, to find that angle, we know the distance. We need to find the distance from that to that. Because this is a right angle triangle. If you draw a point from the center to the circumference, that will be the radius. And then if you draw a tangent at the circumference touching that point, that will be at right angle. Because it's right angle, and we need to find this angle here, well, so we need 2 sides in this case to find that angle. And what do we need to do? We need to find the distance MP. If we can find the distance MP and we know the distance MT, we can find the angle. So to find the distance MP, using Pythagoras, MP squared will be equal to, well, we use this formula called y2 minus y1 squared plus x2 minus x1 squared. This is x1, y1. This is x2, y2. And therefore MP will be equal to square root y2 minus y1 squared plus x2 minus x1 squared. And the distance, you can see we can find the distance MP now by plugging in those values for coordinates for the 2 points. So that would be square root. Now y2 is 6 and y1 is 4. So 6 minus 4 is 2, so that would be 2 squared, plus x2 is 12 and x1 is 6. 12 minus 6 is 6, so that would be 6 squared. So that's MP, and that gives square root of 4 plus 36, and that will be square root of 4t. So the MP is root 4t. We could simplify if you want, so that would be root of 4 times 10, which is root of 4 times root 10. That will be 2 root 10. Now we know the distance. We can, so that is root of 40. Now we know the distance. We can find the angle here. Now we have, because it's a right angle triangle, we have the angle here. This is the opposite of the angle. This will be the adjacent, and this will be the hypotenuse. What has adjacent and hypotenuse? So we're thinking of using SOHCAHTOA. So if we say SOHCAHTOA, and what has adjacent and hypotenuse is CAH. So we're going to use CAH. That means cos of the angle M will be equal to adjacent over hypotenuse, and the adjacent is 3 over root 40. In order to find M, we divide both sides by cos, so that will be 1 over cos 3 root 40, and that will be, well, 1 over cos in indices is cos to power minus 1, 3 root 40, that's root of 40. And so now we could use the calculator to find that. Again, we have to make sure the calculator is in radians. Turn on the calculator. Look at the top of the screen. If the top of the screen shows R, it is in radians. If it doesn't show R, it may be in degrees or any other form. So you need to click Shift menu, and then 2 for angle unit, then 2 for radians. And then if you look at the top again, it should show radians. And that's good. Now we can plug in we need cos inverse. So you do Shift cos, that'll give a cos inverse. And then you need a fraction, because there's a fraction in the bracket. The fraction key is below the option key. And then 3, move the arrow down, and then root 40. Move the arrow to the right side and close the bracket, and you get 1.0766, just as required by the answer. So that's the M. The angle is 1.0766 radians. The shaded region TPQ is bounded by the straight line TP and QP and the arc TQ as shown in the diagram below. So that's the area we're talking about here. Find the area of this shaded region TPQ. Give your answers to 3 decimal places. We've got this region here, and again we got the right angle triangle. We know the angle here because we worked that out earlier. That angle is 1.0766 radians. So what we need to do is to find the area of the right angle triangle, because that's a right angle triangle. That's a right angle triangle. We need to find the area of the right angle triangle and take away the area of the sector from there. So we know what the sector is. This is a sector from there to there. That's the sector. And the sector has that arc length. There we go. That's a sector there. So to find the area of the shaded, it will be the area of triangle minus the area of the sector. Now, how do you find area of a triangle? Area of the triangle is half base times height. Now, we know the base is 3, and the height here, I'll call that h, TP. We can find that using sine. Sine of the angle, if you look at the sine here, sine is opposite over hypotenuse. So sine of m, we know what m is opposite. The opposite is h that we're looking for, the height, over the hypotenuse. The hypotenuse, we know what that is. That's root of 40. Therefore, m, we now know what m will be. Oh, we know what h is. So h, that implies that h, multiply both sides by root 40. H will be root of 40 sine m, and m is 1.0766. So we know what h is now. Now to apply the area of a triangle, area of the right angle triangle, and that will be a half base, which is, the base is 3, times the height, which is root 40 sine 1.0766. Again, remember, we're working in radians. So if we're working in radians, you have to make sure your calculator is in radians. If it's not in radians, look at the top screen. You will see the R. If there's no R there, you need to change it by going to Shift menu, 2 for angle unit, and then 2 for radians. You'll see R there. Then you can plug those values in and do your calculation. Okay, after plugging those values in, you should get 8.352. So that will be the area of the triangle. Now, we need to find the area of the sector. So area of the sector is basically a half. So we go area of sector, that will be a half r squared times theta, and a half 3 squared times theta is 1.0766. Again, if we plug that into calculator, we get 4.845. Now the area of the shaded part, so area of TPQ will be the area of triangle, which is 8.352. You can see it's bigger than the sector, minus the area of the sector, which is 4.845. So that should give us 3.507 unit squared. And that's the answer we're looking for. just to remind us, what I've used there is a half base times height for the area of the triangle.